This question says use the graph of the function f to solve the inequality. F of x is less than 0, f of x is greater than or equal to 0. So I'm going to take a minute to draw on my picture before I get started. And what we really need to pay attention to is that this f of x being less than 0 is the same thing as saying y is less than 0. So I'm going to pay attention to my y scale, and for my y scale, any points that are on the x-axis, those are our x-intercepts, and all x-intercepts have a y-coordinate that is 0. And then every point that is above the x-axis is going to have y values that are greater than 0. And then all of the points that are below the x-axis are going to have y values that are less than 0. So when I'm looking at my picture for the first one, I'm looking for when f of x is less than 0 or y is less than 0. So I'm looking at all these pieces that are below the x-axis. And I want to write down what x values have a y value that is less than 0. So for this piece of the graph, that's going to start at an x value of -2 and end at an x value of -1. So it's going to go from -2 to -1, and then starting at a y value of 0 and going to an x value of infinity. So the answer to this question of when is f of x less than 0, that's when my x is from -2 to -1, or from 0 to infinity. Then the other part says f of x is f of x is greater than or equal to 0. So now we're looking at the pieces that are above. Greater than 0 is above the x-axis, and also equal to 0, so we're going to include these x-intercepts. So when I'm indicating this piece right here, this piece is going to start at an x of -infinity and go all the way to an x of -2. This time I'm going to put a bracket on -2 to include it. And then I want to write this piece here, which starts at -1. I'll use a bracket, and stops at 0. Use a bracket. So f of x, my y values, are greater than 0 when x is from -infinity to -2, including -2, and -1 to 0, including both -1 and 0. Thank you for checking out my videos. Have a great day.